quadratic functions that are in vertex form. We're going to identify the rule and transform it from its parent. So our parent, or quadratic, is f of x equals x squared. And our new function that we're going to graph, that we want to graph, is our g of x, our child. And we have two transformations going on in this equation. Let's talk about the easier one, I would say for students, is that minus 2. That minus 2 is outside the function. It affects the vertical axes. It's a minus 2. So it doesn't change the shape of the parabola, but it's going to move it down. So vertical shift down 2. So we are going to change the rule for our y's from its parent by subtracting 2 from all of the y's. All right, the next thing is we have a multiplier of 3. That's also outside the function. It affects all the y values. The number is greater than 3, or greater than 1. So it is a vertical stretch by 3. So we're going to be multiplying all the y values by 3. And we're not going to do anything with any of the x's. So again, if you want to look back at your chart here, the first thing we noticed, it was a minus. So that shifts it down. And we're going subtracting all the y values by that k. The other thing was in front of the function, it was a number greater than 1. So we're going to be multiplying all those y values by that multiplier of a, and it's a vertical stretch. So there's where we got those two things from. All right, so what we're going to do next is go ahead and graph its parent. So if you remember, the parent is f of x equals x squared. Here are 5 numbers for the parent that we'll graph out. So negative 2 times negative 2 is 4. Negative 1 times negative 1 is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. All right, let's go ahead and graph that. So 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. So we get our quadratic function graphed out. All right, now after we've written the rule, we're going to be multiplying all of the y values by 3, and we're going to be subtracting all of the y values by 2. So what we can do is we can take all of these x's and just rewrite them to that third column. We're not affecting anything on the horizontal axes, the x values. Now with the y, we're going to take all of these numbers and multiply them by 3 and then subtract 2. So let's start with this one. 4 times 3 is 12, minus 2 is 10. And the next one. 1 times 3 is 3, minus 2 is 1. This one. 3 times 0 is 0, minus 2 is negative 2. This one. 3 times 1 is 3, minus 2 is 1. Last one, 4 times 3 is 12, minus 2 is 10. Now, when we graph our new parent, I'm just going to color these, I'll circle them. We're going to graph these as our child. So the first order pair is negative 2, 10, negative 1, 1, 0, negative 2, 1, 1, and 2, 10. So if you remember, our critical point for our parent was at the origin, 0, 0, which is also what we call our vertex. We've now shifted it down to 0, negative 2. Our domain for our parabola is all real numbers, or negative infinity to infinity. And then our range, we graph this horizontal line here. Everything above that horizontal line of y equals negative 2 is our range. So we say y is greater than or equal to negative 2.